Welcome back. We continue with ORS. Here we have a visualization by MeshGrid of a cargo hold overloaded, but the MeshGrid would be the same in case we have alternate loading. So we have one hold loaded and the holds next to it are empty, and this one is also empty. The MeshGrid would be the same. There are two items important for officers. For naval architects, they're all important. And the first one is the increased stress at hatch coming and hatch corners. If there's deflection of the hatch coming, the hatch cover on top of the hatch coming might not close properly anymore. If it doesn't close properly anymore, it means that the cargo hold will be open to the seawater. So if green water is reaching the hatch coming in that case, the water will enter the cargo hold. And this is, as you can imagine, very dangerous. Another important one is the stresses on the transverse bulkheads. They are usually conjugated, in Dutch vouwschotten. In case of alternate loading, there's no back pressure from the empty hold in the direction of the loaded hold, and the transverse bulkheads, they are bended a lot. And this bending causes, as earlier said, that the hatch coming in the middle comes a little bit more down to the inside. And that's, as earlier said, is a risk for the connection between the hatch cover and the hatch coming. Another risk is, of course, the increased stress on the double bottom structure. If there's too much weight, maybe stiffenings in the double bottom can collapse, and that's a very big risk for the integrity of the ship, and maybe the ship doesn't stay seaworthy and it might gonna leak, or we get certain stresses that the steel of the cargo hold is imposed by cracks or small dents, etc. Just bear in mind that on the average the compression of a hatch cover rubber is about 1 centimeter. So if the hatch coming deflection is more than 1 centimeter, it might mean that the rubber isn't touching the hatch coming anymore. I go to the next sheet. Well, oars don't need specific attention. Nevertheless, it's not an easy cargo. You really need to know what you're doing. Oars contain water, and water flows to the bilges, and the bilges need to be emptied and drained. The weight loss due to this emptying of the bilges needs to be logged in the ship's journal. And the reason of it is that if you arrive in the port of discharge, all the water what is pumped out is like a shortage in the total amount of cargo. So they expect you to deliver 200,000 tons of ores, but you have pumped away 10,000 tons of water. They think you are cheating them with 10,000 tons of ores. And that's the reason why you need to put down in your ship's journal how much water is bilged away to the tanks or to the sea. Ores can oxidate. The hold becomes a confined space. Basically, it means that the ores have a chemical reaction with oxygen in the air. If we have an enclosed space, the percentage of oxygen will lower from 21% till a lower amount, and this imposes a risk for human life. So you need to wear breathing apparatus if you enter the hold, and you need a certain procedure if you want to do so. Discharging, the paint within the hold gets damaged, often also due to this grabs, also stiffenings, frames. They might get dense or they will be touched and they get bended. Longitudinal forces, the combined discharge and ballast plan needs to be planned correctly. All the steps you take need to be checked in the computer, and you need to safeguard that you don't exceed bending moment and shear force limits. And you do that in the stability program. All the steps, step by step, you calculate. Another risk is acid from cargoes having a bad influence on the side frames. We are actually looking at the top side tanks and the lower hopper tanks. What happens if we have a cargo which is slightly acid? If the paint isn't properly applied on the side frames, the acid might reach the steel underneath the paint surface, and it's gonna weaken the steel, and that's a worrying thing because it can impose a risk on the weight it should be able to carry with all the other frames if the hopper tank is filled, the top side tank is filled. So it's common to weigh the bulk cargo for multiple reasons. The amount of tons loaded and stated on official cargo documents, for example, a bill of lading, we need to know exactly, precisely how much we transport. It's also to prevent a shortage claim in case of the ores with the water. You need to bilge away the water. You need to have in your journal how much water is lost to make it even and not to get a shortage claim. If the amount is different, you can lose your insurance cover. And it has something to do with preventing overstressing the hold, the structure of the ship. It needs to be precisely in the papers in case you get a problem. In case you weigh in a precise way, you can better keep track of your loading and deballasting plan, and the risk of loading deeper than the maximum draft mark is less. So we go to the last part, then we have one movie. With bulk cargoes, especially with small particles or dust, there's a risk of dust explosion. And a dust explosion is basically a rapid explosion, combustion of small particles. And due to the fact that the oxygen surrounds the particles well, the explosion will be more rapidly than an ordinary combustion. So because the particles are small, the oxygen molecules will surround the particles better, and the explosion will be more rapid. Please watch the last movie